Okay, I will start. Hello. I'm here to talk to you about how I FRP'd my Swift. Um, for those of you who writes Swift here? Oh, nice. And who uses FRP? Cool. For those of you who never used FRP, this might seem like kind of daunting at first, but you will see that this is going to be like a smooth breeze, and at the end you'll be like, yes, this is going to be the future of programming, like I did like some months ago. So, a little bit of context. I am Afonso. I work at Embabel. So at Embabel, we aim to be the world's translation layer. I don't know if you had the chance to catch Vasco's, one of our co-founders' presentations this morning, where he set the vision of Embabel. And at Embabel, I build basically mobile apps. And when I need to, also I need to do some web interfaces. I'll be live tweeting this talk, some pieces of information that I think are useful, and to maybe start a conversation between us all and whoever sees this is seeing this online. And also, like, if you have any doubts and we run out of time for questions, that could be like also a way for us to continue this discussion. So, how many of you have apps in production that run 100% Swift? Yeah, that's kind of a bummer, right? Like, I want to start this app in Swift and I can't because I have to keep up with this legacy code that I have of Objective-C. So at the beginning of the year at Embabel, we had this idea. Let's reimagine our mobile apps. And we have all the freedom you want. You can start them from scratch if you want. So I saw that as a chance as, I will do Swift. And as we were developing the new architecture of the apps, some friends were like, are you going to use FRP? And at the time I was like, what? FR what? And then they gave me a brief explanation and I was like kind of intrigued by it. And at the same time I was like, whoa, this seems very difficult. And then I went to investigate a little bit further. And I ended up using it. And that is kind of the result of this talk, like the process of learning what FRP was and how it helped me build Embabel's new app. So before we head first into like theory, how did you get to PixelScam today? Bus, train, Uber. Okay, so we were at Embabel's office and we had to carry the VR and all that stuff, and we were like, how are we going to get there? And yeah, we decided to come by taxi. And the taxi arrived and we had two options to tell the driver where we wanted to go. So the first option, we would go like turn by turn and say, go forward, turn left now, turn right, like a GPS, and eventually arrive here. Or we could just go like, take me to LX factory, please. Both achieve the objective at hand, but they have fairly different approaches. You could say that one of them has an imperative approach to programming, while the other one has a declarative approach. And what makes them different? A lot of things. As an imperative approach, you focus on how you're going to achieve something. You build a certain number of steps to achieve an objective, and in the end, you'll have to keep some state and keep mutating it until you reach your goal. Whereas in the declarative side, you think of what you want to achieve. And it's fairly interesting that it's context independent. So the example before of the taxi, if I was not at the office and I was, for example, in Caixdre, that option could still get me here. The first option, not so much. I wouldn't know where I would be right now. And the declarative approach kind of make it simpler and more readable, reducing the amount of incidental complexity that you would find in the problem itself. So does that mean that I should only code in a declarative way? And my answer to that is probably not. Like Fred Brooks said, there's no silver bullet, and we cannot be purists to think that we can only write code in a declarative way. We still need to ship code, and sometimes we will have to write imperative code. And I think that both of them have pros and cons. And what we need to think of is we need to strive for a balance between both in our code bases. Because, for example, if you want to have performance and you have you're only using a declarative approach to programming, most of the times you're relying on some sort of an abstraction over an imperative approach. And that abstraction has to be general enough for to be used in almost all the cases. But if your code really needs to be performant in some situations, it would be better and more optimized to be an imperative approach. But how can we achieve this kind of balance? That's where the functional reactive programming. Now I'm going to start calling FRP because it's easier than to always go functional reactive programming. Comes into play. So FRP only thinks about behaviors. FRP doesn't think. You don't need to think about what's going to happen to the future to an object, what happened in the past, in what context that component or object is being used. You just have a component and you define that the behavior it is supposed to have, and that's it. And to achieve that, FRP has like three main ingredients: sequences, transformations, and bindings. A sequence is kind of like an array of stuff, any stuff, but is a better array because it's an array with another dimension, which is time. So if an object goes in and you're looking at it, you will see it. So in case if Mario is just standing there next to the pipe, when the plant comes, he will see it. Another great thing about sequences is that it abstracts the type of content that it's inside it. It doesn't really care. So again, with the pipe example, the pipe doesn't really care if it's the plant or Mario going in. The behavior will always be the same. Go in and it will go out in the other hand. So transformations. Transformations are, so a transformation picks up the object that it's inside an observable and it just plays with it and does whatever they want to do as long as in the end it will send out another observable. So what does this mean? They send a new observable, so it means that it's not mutating the old observable, and they do not create these kind of side effects. So probably the functional programmers in the audience will be like, yes, it will be clean. And it also has the advantage of, since they are always throwing out an observable, you can chain them together. So imagine if Goku wants to reach Super Saiyan 4, he just needs to chain up, level up 4 times, and it will get there. So, and it leads us to bindings. Bindings is what glues all of this together. It's what makes this FRP all mumbo-jumbo work, and it's kind of like what makes it awesome. Because you could have like sequences of emails, of apps, of media, and then you have like all these complex transformations, but what would happen if you couldn't bind it to the iPad? Like, it would be kind of useless, right? So there are a lot of flavors of FRP for Swift, and I kind of went with RxSwift. If you ask me why, I wish I had like a like an opinionated and a very structured answer for that. But the thing is, it was the first one I tried, and it was so simple and intuitive that I kind of was sold at first time. Like, I don't need to try anything else. Like, this is it. This is good. So how does it map to the FRP that we have already learned? So sequences are observables, and these are things that you can observe to. Transformations are functions that return observables, and they can even be like the high order functions that we have, like map, filter, and reduce. Also, you can also create your own transformation methods as long as they return an observable type. And bindings are bindings to certain objects in the code, or are subscriptions to some events, and that you don't have to do anything more about it. You just need to remember to have a dispose back. And why? Because all this immutability and subscriptions, this retains on objects in memory. And as those of you that develop iOS, retain cycles are a big no-no for the apps. Like, the memory starts to go up, and then the users start uninstalling the apps, and that's no good. So basically, a dispose bag, what it does is it keeps track of all the subscriptions that have been done, and it guarantees that by the time the view controller is deallocated, it cleans all those objects from memory, so you don't have to worry about that. So, the million-dollar question: how did FRP help me to achieve my goal of building a new Embabble app? There's nothing better than to show you how it helped me than through live coding. So, to give you a setting, can you read, or do you want me to put the font bigger? It's fine? Okay, so as I said before, we were in the process of developing, of doing the architecture of the new mobile app for Embabble, and at the same time I was learning FRP. So I could not really just stop for like a week and be learning FRP. So I was like learning for a bit, coding view controllers during the afternoon, learning in the morning, and I just went back to one of the early times of the app and took a snapshot from Git of how the code base was, and I look at it, and to be honest, I was kind of embarrassed. Like, I think this is what happens when you like look at your code like 6 months ago. You're like, did I really do this? So ever since then, I've learned a lot more about RxSwift, and I've spotted some things that I could have done much better, and that would save a lot of code. And I'm just going to show you right now. So the example in question is the login page for Embabble. So this is fairly simple. So I would the sign in button is not enabled, and it will only be enabled if I write my email and a password. If I remove it, if the email is not valid, it's not, the button is disabled again. So how did I achieve this? I'm very sad to say that I achieved this in a very, very bad way. It's a very imperative way of achieving this. So basically, I made the controller conform to the delegate of text field, and I made the text field's delegates to be the view controller, and every time the user would type, I would check which text field, what was the text, how the current text is. Then I would have to check which of the text fields was being changed, and compare it and see if they were valid, and set the button to enabled. or disabled. And then for the password, the same thing. This is a mess. And to be honest, like, if I had to show this to anybody, I'd be like, Jesus, did you really think this is good code? Yeah, so I'm going to show you how I would do it now with RxSwift and with the help of FRP. So I would start by doing this and this and even this. And then, just because I have a lot of lines of code that from the other version, I can do a lot of code and still have less lines of code. So I'm going to create just a marker for my extension, and I'm going to create a function to set up my Rx. And now, because I'm feeling fancy, I will create some intermediate variables just for readability. So I'll say intermediate. And like, is email valid? And I have the text field. And I can, this is an observable of the text that it's inside the UI text field. And what do I need to do? So I have an observable of a string. So I want to know if it's valid, so I might as well just map it to a Boolean. So how do I do this? I would just map it to my validations function, is valid email. And this is a great thing about Swift, is that if now you see, like, it already knows that it's an observable of a Boolean, even though I started with my UI text field. So I should do the same for, I'm kind of lazy, so I'll just go like this, and here it's gonna be my password, and here it's for the password. Okay, so now I have both observables for my Boolean, for my fields that return Booleans to tell me if they are valid or not. So what do I need to do now to make the button go like enabled or disabled? So like I explained before, we just need a sequence of things, transform it, and bind it. So basically, what I'm going to do is like, I'm going to create an observable that combines the latest observables of the is email valid and the is password valid. And I'm just going to tell it like, okay, and this now will give me one Boolean. And then what do I need to do more? I'll just bind it to the button, to the observable of the enabled button, which we can throw things at. And well, what's this? Yeah, remember what I said? Never forget the dispose bag. Otherwise, then you'd have retain cycles. There you go. And this should be good, and this should run, right? Okay, let's see. This seems like a good email. Uh-oh, should be working. This is the problem of live demos, right? You think things will work, but then they won't. You know why it's not working? Exactly. I defined like the function here. I'm just not calling it. So if I do, like, there's no reason for it not to work. Let's see now. Now if it doesn't work, I'm gonna be like, okay. Let's see. Yeah. Oh, look at that. It's working. What if I take out the... It's working again. And with 7 lines of code and a call to a function and counting with 2 intermediate variables and a comment compared to like all of this, this is very powerful. It's a very powerful way of programming. But I'm still not quite pleased with this solution, because for every key press that the user will do, like, this is going to get called. And typically persons don't write just one. They are fluid. So once they're finished writing, you should check it. So why not just like, I go here and I will just go like, I'm going to debounce it for like half a second, and I will debounce on both, I guess. And it should work again. And it's a more optimized version of my original code, because it's using less resources of the phone. It doesn't have to run like every time a user presses a key to check if they are valid or not. And now this should work. Yeah, it does. So with, let's say, like 11 lines of code, I have a better version than I had before, with a delegate, with a conforming to a protocol, having 2 delegates set, and be checking, and use a function that was not meant to do what I was doing it in, to check if the button should be enabled or not. So this is the real core of FRP. I could even like continue on this, and I kind of noticed that the FRP that I had before is, right now I look at it and I think I could do it better. So basically, what is happening here is I'm using another framework called Moya that basically does a request, and what it does, I will show you. It creates the request and returns an observable of the response. So in my view model, what I do is I have a variable that, I'm not showing you the correct code. Yeah, this should be good. So I have a variable which is a type of an observable, but it's an observable that if it errors out, it doesn't kill the sequence. And I basically do a call and propagate something to the variable saying the state changed. So actually we are not saving any state. We don't have a variable saying like, this is my state right now. What I do have in my view controller is a function that looks at my current state and is subscribed to it. So any time that state changes, it gets notified that it changes. And then it just needs to know what kind of change it was. If it was like there was a login, or if there was some sort of problem with a login. And this way, you don't actually need to save any state. You don't need to save any variable saying if you're logged in or not. It's just a change in the state, a change in that the network sent, and that's it. So going back to my slides. Boom. This is kind of like magic. So we had the same functionality. I did the math before, and it's 70% less code. And even with an optimized version, it's 60% less code. So imagine if you go in at 9 with the same functionality, you'd be leaving before noon, and you would have done a full days of work. And even with the optimized version, you'd leave before midday. It would be great, right? Like you just work like half a day and have done all the work. And overall, the readability is improved by a lot. So if I had to onboard someone to that project, that behavior is contained, and it's fairly easy to understand what's going on. It kind of like reads like English. Like you have this, that it's a text, and you map it to see if it's valid, and then you bind it to something else. It's understandable. And not only that, it's context independent. I could pick up that code, the same login, and put it in another project, like by copy pasting or something. No, don't copy paste. Create a framework for that. But anyway, it's the power of functional reactive programming is that you have just a behavior that doesn't have to deal what's the context around it. So, do you want to learn more about functional reactive programming? There are a lot of resources out there. You can start with this demo. I put it online on my GitHub. If you want to go directly into RxSwift, I really recommend their playground. It's amazing. It goes like in depth with all the types of observables, the types of transformations that you can do, bindings, etc. It's really powerful. If you're having some trouble like understanding how is the flow, how the flow works, and what the transformations do to the content, go check out Rx Marbles. They have some interactive graphs with like those marble graphs, you know, like there's a timeline, like events, and you can move them around and understand what's happening. If you want to learn more about the theory, you have the reactivex.io, which is actually the project that started all this. So ReactiveX is a project started at Microsoft, I think, that started this whole idea of combining the best things of the observable pattern, the iterator pattern, and functional programming. And basically, a lot of people liked that idea and started to write that same philosophy in a lot of different languages. So I'm talking about RxSwift, but actually there's a ton of other packages for other languages. There's RxJS, RxJava, RxKotlin, you name it. You can use it in any project you want. And if you really think that, is this something that I can use in production? So I would advise you to go check out Ash4o's artsy app called Eidolon. It's completely open source, and it's running in production now, and it's using FRP and RxSwift. And it's kind of amazing what it can do. So that's it for me. Thank you for being, and I hope I kind of sparked the idea of FRP into those of you who never tried it. and maybe you will use somewhere along your projects. And if you have any doubts, reach me on Twitter or go to GitHub and open an issue on this demo, and we can talk about it. Thank you. Okay, cool. Does anyone have questions?
Why did you go with the RxSwift instead of Cocoa?
Like I said, it was someone told me like, you should try FRP, and I looked it up and I saw like, yeah, there's RxSwift, there's RxSwift, there's Reactive Cocoa, and RxSwift was just the first one I tried, and it did everything. It was everything I hoped, so I didn't really need to go look out for anything else. Do you use some?
I used before with Obj-C and then
okay.
Swift and I think you need the same one. But yeah, it's kind of the same. Just sends the signal producer signal instead of observables.
Yeah, probably they have like special functions or no?
I think it works to UI, for example.
Oh, okay.
I need to use X. It's an extension of the Reactive Cocoa to use with the UI key. But I want to move to Swift 3, for example, right now, and I can because Reactive Cocoa is moving and the version 5 will be supporting Swift 3.
Yeah.
Are you using Swift 3?
Yeah, not right now because because of dependencies on other libraries. So Moya I use Moya for my networking, and Moya hasn't still released the support for Swift 3, so I'm stuck in Swift 2.3. Yes, it is.
It's like Moya is already native.
Sorry?
Is Moya native already?
Yeah, you can use Moya with you can use it with Reactive Cocoa. You can use it with RxSwift. I think you can even use it with RxSwift. I'm not sure. I'm not sure, but at least those two you can for sure you can. You should give it a try. It's
I use Reactor. It's kind of the same.
okay.
It's from my line.
Okay.
It's the same as Moya.
Okay. Cool. Does anyone have any other question? Okay. If you don't have questions now, it's okay. If you have questions later, if you're trying it out, just tweet me, and yeah, let's have a conversation about it. Thank you.